Hi, it's Mrs. Moret with help on the assignment Unit 2, Lesson 18, Practice Problems. This is in your textbook on page 199 through 201, and you're doing all of numbers 1 through 6. All right, so the number 1, rewrite the rational function g of x equals x minus 4 divided by x in the form g of x equals c plus r divided by x, where c and r are constants, so just numbers without variables. So we did this in class today. What we're going to do is take a function written as one fraction and split it up into 2. Okay, so to do that, we will just distribute basically this dividing by x. So our first step is to write it out. G of x equals x divided by 4. Sorry, x divided by x minus 4 divided by x. All right, and we've got one more step. So x divided by x is just 1, and then 4 divided by x can't be simplified. So our final answer is g of x equals 1 minus 4 divided by x. All right, for number 2, the average cost in dollars per mile for riding X miles in a cab is C of X equals 2.5 plus 2X divided by X. As X gets larger and larger, what does the end behavior of the function tell you about the situation? Well, again, if you think of this function, and you divide it like we did in number 1, so 2.5 divided by x plus 2x divided by x, which altogether 2.5 divided by x, and then this can be simplified. 2x divided by x is just 2. So I know that if I were to graph this, there'd be a horizontal asymptote at y equals 2. And so again, if we look at this on the graph, which I've got here in Desmos, okay, so this is what the graph looks like. And I can see that it appears to be approaching 2. And as I go further and further out with larger and larger values for x, it starts to just look like a horizontal line because it's so close to y equals 2. So about the situation, though, remember this function represents the average cost per mile for riding in a cab. So I would say that as the miles increase, the cost per mile gets closer and closer to $2. All right, on number 3, we have a graphing problem. So I can see the graphs of these two rational functions, f and g, are shown. One of them is given by the expression 2 minus 3x divided by x. Which graph is it? And explain how you know. So again, if we can see the horizontal asymptote when it is written as one fraction, but it's so much easier to see it when you break it apart into 2. So I'm going to divide both of these terms by x. So 2 divided by x minus 3x divided by x, and that is equal to 2 divided by x minus 3. So I know that there is going to be a horizontal asymptote at y equals -3. So the first graph has a horizontal asymptote at y equals -3, and the second one has a horizontal asymptote at y equals +3. So since I can see from the equation, I need it to be the -3, then f of x is the correct answer. F of x has a graph with a horizontal asymptote at y equals -3. All right, number 4. Number 4 and number 5 are revisiting polynomial functions from the first part of this unit. And so it says, which polynomial function's graph is shown here? So since these are all in factored forms, I'm going to look at the zeros or the roots and think about if these are the zeros of the function, then what would the corresponding factors be? And remembering that the zeros are the value of x that make the factor equal to 0. So for this root or 0 of -1, the factor would have been x plus 1. Because if I substitute a -1 here for x, I would get an answer of 0. For the root of x equals 2, the factor is x minus 2. Again, substituting a 2 in for x would give us an answer of 0. And then the same reasoning for this last root or 0 at x equals 5. The factor would be x minus 5. So the answer choice with those three factors is B, and that is the correct response for number 4. Number 5 is also about polynomials, only this time it's asking for the degree and the end behavior. So let's remember the degree comes from the largest exponent on the variable in the function, which it appears to be this is the power of 3, power of 4, x to the second, x to the first, and then that's the constant, so x to the 0, really. So this is going to be our leading term since it has the highest power of x and the exponent is 4. So the first part of the answer is that the degree is equal to 4. Now, since 4 is an even number, I would say this is an even polynomial, and the leading term is negative. So while I might use that combination to determine the end behavior, that is not how I state end behavior. I also can think about what does the function look like on the ends? Well, it's going to look like this on the ends. It might have some different parts in the middle, but we're just focusing on the ends here. Again, this is just thinking and work because of the question. It is not answering end behavior. To actually describe end behavior, you are going to write sentences with words. So as x gets larger in the negative direction, y is also getting larger in the negative direction. And as x gets larger in the positive direction, y gets larger in the negative direction. So I can state this end behavior since the same thing's happening on both ends. I can state it with one sentence. So as x gets larger in both the positive and negative direction, f of x, because this is f of x, gets larger in the negative direction. Okay, it's pointing down on both ends. All right, and then our last problem on this assignment, number 6, is revisiting vertical asymptotes from last week. So still rational functions, but vertical asymptotes rather than the horizontal asymptotes we worked on today. The graphs of two rational functions, f and g, are shown. which function must be given by the expression of 10 divided by x minus 3, and explain how you know. So I noticed the first function, y equals f of x, that graph has a vertical asymptote at x equals 3. And then over here, y equals g of x, that graph has a vertical asymptote at x equals negative 3. So that's going to be how I determine which graph will go along with that expression. So remembering back to last week, okay, sorry, my camera froze there for a second. So remembering back to last week, I can recall that we figured out vertical asymptotes by thinking about what value of x would make the denominator equal to 0 so that the fraction is undefined. So we solve this x minus 3 equals 0 by adding 3, and that gives us x equals 3. Okay, so it looks like the graph of f of x is the correct response because it has the vertical asymptote at x equals 3. And that is the end of your assignment. I hope that was helpful.